Hello everyone and welcome to another RavenDB webinar. In this webinar we're going to talk about an awesome new feature. We call it dynamic aggregation. As you know, right now RavenDB can only do aggregation through MapReduce indexes. For that matter, let's look at this. Let's assume that we have the following structure: order and currency and whatnot. If we look at the data, this is what the data looks like. Now, if I wanted, it would be very easy for me to ask questions such as, okay, let's give me the total per product, let's give me the total per currency. This would be something like this. From in docs.orders, select new product, o.total, and then select new product equal g.key, total equal g.sum. So I do this, and this is very, very easy to get results. We get the appropriate result. Everyone is happy. Notice, by the way, that when we actually make this query, let's see it from scratch, make this query, the actual time that we spend doing the query, and we're talking about with 10,000 results, is effectively nil. Now, the problem with this is that there is a limited amount of querying that we can do. For example, if I'm going back here, I could very easily say, okay, give me by product, give me by currency, but it would be somewhat hard for me to do things like, okay, give me by product and currency. I can do a MapReduce index that does both. If we go here, let's handle that. Currency, new r.product, r.currency, and now I have to do and coming back here, it's taking some time to recalculate itself. Sorry, that is still something that we need to fix. Orders all. Huh? That's interesting. Did they do something strange? I don't think so. Forcing the index to be reset. Okay. Properly save it. Good. Okay, so there appears to be some problem with this index. I will keep it for later and then try it out, but you get the point. I would be able to do a group by on the currency and product and get everything for a currency and product. This is all nice and good, but it doesn't let me answer a very big problem. Let's say that I want to do additional filtering. In this case, let's say that I want to get the total for product where I want the total per product, where the total only for orders where the total is greater than 500. So if I was doing that in SQL, I would be writing something like this. Select star, select sum total from orders with total greater than 500, group by product. Something like that. Now, the problem is that right now, this is quite hard to do in RavenDB. So we set out to figure out a way to resolve that. This is what we came up with. And now we want to use where. Okay. So this is pretty much the equivalent to that. Let's see what happens when we run this. Seriously? 1 second, I think that I need to... So I'm running this, and now you can see that I'm getting the right results. This is the product. Now we have this is the product facet. Now we have here all of the product that we have for this, and the total sum for that. So the basic idea is this gives us the ability to actually handle these sort of queries very nicely. We do all of the aggregation dynamically, and we're able to answer more complex queries more easily. And just to check. Yeah. Okay, so it was fine. It just apparently, so this index was fine. It just apparently took some time to compute for whatever reason. But so you can see that here we have euro and product, and I can say stuff like currency 0, filter by that, but I wouldn't be able to filter the output, the total. I'm only able to do that if I actually took into account that when I'm building the index. That's the major difference between this approach and standard MapReduce. Now I'm going to open the floor for question, and then I have some talking to do about this feature. Anyone wants to ask a question? Going once. Guys, we have relatively few people on this webinar. We can just, oh, we have. Okay. So here we start. Okay. So let's start with Troy's argue. I assume that order all is a map only index. Almost. Let's look at the order all's index. As you can see, it's a standard index. The only difference is that we need to tell Raven what is the data type for the total. We do that using the sort options. And the reason that we do that using the sort options is that this tells us whatever this is a double, int, long, or whatever that is. And that's all. This is an absolutely normal index, except for that. And you can do that on any of your own indexes. The only two things you actually have to worry about is, I'm actually going to need to have the filtering criteria inside the index, and I need to tell RavenDB on the field that I want to aggregate on what type it is. And Daniel is asking, when should it use that instead of an index? Well, that's a very complex question, but the easy answer is that whenever you have to do queries that you literally cannot do using MapReduce. The reason that we still want to use MapReduce is that MapReduce, the answers that we get are already pre-computed. There is very little work that has to be done. Compared to that, in this case, what we have to do, let's do it like this. Okay, and let's see how much work we have to do. Okay, so compared to this, we still have to go and manually touch, about half the data set. In this case, we have about 10,000 items, and we pretty much touched the entire data set. As you can see, this happened very fast. We tested that with data sets of million of records, and this is still fast enough for most purposes, but it's still, you have to touch a lot of data. So that's probably something that you want to be aware of when you start working with that. We want to reserve that for only the cases where we actually cannot answer the question using MapReduce. More questions? Going once, going twice, and we have more questions. Yay. Okay, so Troy is asking, this uses facets under the cover. And the answer is yes. Under the cover, this is basically using the facets. We extended support for doing additional aggregations. You can see that we have, we can actually do something like this. Yes. So this basically is facets, and we extended this to do aggregation on multiple levels, on multiple operations at the same time. I think this is pretty cool, and that's it for me. Okay, let's see if anyone has any more questions about this topic. If not, do you have any questions in general? Going once, going twice, and that was a very short webinar. But then again, the only thing I wanted to show is that this specific feature, and I think it's a really sweet one. Okay, guys. So Daniel is asking, can you show us transaction merging? No. What actually happened is that we took that out in favor of concurrent transactions. I'm not really sure. Okay, so a while ago I posted about let's see. Okay, so this is probably the post that you're talking about, and okay, so this is the transaction merging. This shows how we did it, and the reason that we wanted to do transaction mergers is because we wanted to push as many writes as possible on a single thread. Something else that we did is improve the write perf, and we did that by removing transaction merging and instead going with concurrent transaction based on Essence ability to more easily handle concurrent writes. Let me see if I can show you how this works. Where is the actual get data? Create data. So this is probably the worst way of creating, of importing data into RavenDB. Unfortunately, what's the problem? Sorry. Generate data. Okay, so this generate data is going to generate 10,000 records, and we're going to generate them in parallel, one at a time. Well, not one at a time. Well, one at a time per thread, and we use however many threads we need to. So the problem with that is that, let's see how much time it takes. So 10,000 millisecond. So let's see how this works. Okay, so we can see here that CPU usage is high because we're now concurrently using all cores to write to RavenDB. Previously, what would happen is that in this scenario, we would have to basically serialize all the writes. This is where transaction merging really helped. Instead, what we're doing now, we're doing concurrent transactions, and we're able to use all the core for this to work. The problem with this is that this means that we have a lot more complexity with regard to ETAG generation, because now you may have concurrent transactions where a transaction is where a transaction is generated an ETAG but didn't commit before, and it was scheduled away while it was still in the process of committing. Then you have another transaction generating a later ETAG, and this one did commit. So we have to support the notion of ETAGs that are coming in the wrong order. That was quite complex to do. So Daniel, what we just did, we imported 10,000 documents. So this took about 50 seconds, obviously. And that was at the speed of roughly about 5 milliseconds per document. Now, the interesting thing here is that we're able to gain a lot of concurrency from doing that. Now, this is absolutely the worst way of inserting data into RavenDB, but think about a very common scenario. Think about this common scenario with running in a web browser, running a web application, where you have a lot of concurrent requests which may modify data. So this really improves us for that scenario. And Daniel, I'm not going to run it for transactions. Transaction has not been touched for this. We're still working on that, and that's, I think, RavenDB 1061, if I remember correctly, the bug that we have for that. Okay, more questions? Yes, so this makes it about 200 inserts per second, and that's mostly because we'll keep competing on the threads, both on the client side and on the server side, and we actually get significantly higher than that if you're using embedded. So there is some space for improvement with regard for with regard to additional performance improvements. As I said, this is about the worst scenario that you have for inputting data quickly into RavenDB. Okay, guys, unless there are any more questions, I'm going to tell you goodbye. And, we do have. Troy, SST tables are not the 2.5 features, and I talked about it in my blog. I will talk about it extensively when I have something that I can actually show you. Right now, I'm still going over the LevelDB code base and still working on that. Daniel, I think I actually showed the streaming API, but let's say that we actually want to do something like this. I want to get all orders. Sorry. And now I can do session.advanced.stream. And while you know what, let's do it like this. Okay, so this is the streaming API. As you can see, I have access to the document, metadata, or whatever. And I'm going to run this now. And this is going to give me however many items I have that are above 500. I think that's actually all of them. So let it run, and okay, we have 2,000 items. 20,000 items. And that's it, guys. More questions? Okay, so now for real, I'm sorry, I know that I said it a few times, but now for real, thank you very much. We'll see you in 2 weeks. Hopefully we'll have some more goodies to show you. See you then. Bye, guys.